All right. Let's start this off. Okay. I saw three new pull requests this week. One to set the minimum allocation size to the optimal I/O size for certain devices. The idea behind this is that there may be new device types coming out. In fact, there are already new device types coming out that want larger than 4K allocation units. But having said that, they may not require it. So there's some trade-off between performance and wasted space and all these different things. So there's some discussion happening in that PR regarding that. Definitely an interesting discussion if you're interested in this whole topic. So yeah, there's that PR. Another new one from Igor to make the shared blob FSCK process much less RAM greedy. Igor, that was a huge win, it looks like. I think you said 12 gigs down to like a half a gig?
Yeah, in my scenarios, it looks like that. It's not always that huge, but it greatly depends on the amount of shared blobs one has. But yeah, in a couple of deployments, I could see like millions of shared blobs in Blue database. So last time it showed like 27 gigabyte of RAM while executing this FSCK.
That's crazy.
Yeah.
Was it like? Go ahead.
Well, maybe we should make additional investigation of why so many shared blobs are present there. But anyway, shouldn't grow that much. So nobody cared about the efficiency of this process at the initial development, and it looks like we missed this potency. So we underestimated the amount of edges we might get.
Yep. Well, excellent job. That's a huge improvement. I think you're right too. If we can do a better job of decreasing the number of shared blobs, that's, I think, a very good investigation. Was this on a real customer cluster that you saw that improvement, or was that just synthetic?
Well, I haven't tried that in the field. I made some artificial testing. Yeah, so, well, actually, I changed the design of this internal data structure, so I believe it should help in the real life as well.
Nice. Excellent job. Looks great, Igor. All right, last PR that I've got here was from Mark Kogan, and that is work on this DB store that we were just talking about a little bit ago. Looks like add config options to set SQLite performance tuning parameters. So yeah, active work on that looks really neat. Definitely would encourage the RGW folks to talk more about it and what they're doing. Okay, let's see. I didn't see any closed PRs this week. It's possible I missed something, but didn't see anything specifically performance related. But we did have 3 updated PRs. Let's see. This one to optimize PG peering latency. Is Neha here? No, I don't see her. Okay. So this one basically, she's going to take a look at. It looks like maybe it needs to be retargeted to master, but in this very narrow case that they have, it looks like they saw a fairly good reduction in peering latency. So that was in this very specific case. So looks like it might be a win. Next PR, the MDS remove subtree map from the journal. Um, this one, a week or two ago, a design documentation was provided. I haven't looked through it yet, but it looks like that there's still ongoing work being done with this, so that's really good. It did receive an update recently. I'm not quite sure what changed. I didn't look that deeply into it, but it's still being actively worked on, which is really good. Okay, last one. This is an older PR from this past summer. Optimize object memory allocations using pools. That one had been kind of stale for a little while, but Gabby went through and added some discussion to the PR, and then I also added a little bit there. Gabby, I really like the idea behind this PR, and more generally the idea of doing more to allocate memory from pre-allocated regions, or at least use memory, I should say, from pre-allocated regions, or maybe even better, pre-allocate objects and reuse them. Any more thoughts on that?
Yeah, actually, I would maybe do a few more things. Most of our objects, they are nested objects. So if you allocate an object within it, you will have other objects requiring more dynamic allocation and so on. So when you allocate a big object like an object node, I think you're going to end doing like 20, 30 calls to malloc or to new.
Yep.
So even if this optimization, you're still going to have to pay all these locks, unlocks, overhead, fragmentation, and so on. If we could design something like a standard object for some kind of operation, which we can do and say, you know what, even so, we should allow up to 75 entities, but normally we don't need more than 8. So let's allocate everything with 8 objects. And so you create the big object and all the nested object inside using some kind of, I don't know, 90 percentile.
Short object optimization.
Yes, and it's not going to be just a short, it's going to be probably the vast majority, because while we do allow a lot of crazy options, the vast majority don't use them. So you should have something for the normal case. Try to get it using a single call, recycle the object. If you need more, then you say, you know what, in that case, I'm going to do some allocation.
Agreed, 100%. If we can have the standard case especially covered by just the parent object without having to have like a bunch of other little things allocated off to the side, only do that in special cases. Could help make this so much better.
So we've been back and forth about this because if the nested objects are all coming from a single continuous memory range, then you're also not going to pay all this memory trashing with L1, L2 cache being paged in and out because the memory coming from all over the place. So everything will be continuous once you get it. Memory prefetch going to get you the whole thing inside. You should get significant performance optimization from the memory layout, and also because you don't pay all the extra cost of doing dozens of small allocations, you don't pay fragmentation. And even so, if you say like when you pre-allocate and you assume you're going to have 8 sub-objects, while in many cases you can have only 2 or 4. But keep in mind that every time you allocate an object, if say it's a linked list, you still have to pay some extra work for all kind of link object and such, while if you put them in an array, you don't have to pay for this. So it is a real work, unlike what this PR seems like, I don't know, a very quick solutions, which might help in some cases, and it's very generic. But if you want to do it properly, you really need to do it. And I would start with something that, like the request object. If we service 50,000 IO per second, then probably we don't have more than 1,000 objects alive. I don't know, find the number of how many alive, because if an operation takes about, I don't know, 20 milliseconds, 10, 20, then you don't have more than like 1,000 alive at a time. So you allocate them with some preset values and just keep recycling them. Eventually it's going to be cheaper because we don't going to fragment the memory, and the memory is going to be more condensed. So I would start with this and then slowly walk the way down the food chain.
And in wall clock profiling, we see the evidence of this regularly. New and delete and object creation and object destruction are often some of our biggest consumers overall when you look at the amount of time spread across the code base where we're doing work.
Yeah.
I have a lower level comment about DPR. There are some design decisions there that I can't say that I question. I would like to really ask the designers why they choose some specific, why they made some specific decisions. For example, why not use EMR allocators? Why not use make use of existing or standard or boost pool memories? There are many existing implementations that I think are better, and at least in one major point are designed better from this. Maybe I don't understand the full set of requirements that they were trying to answer here, but I will add some questions later on, maybe Sunday, to this PR.
I think you should run it. All of this is still up in the air, right? I mean, nothing's really been done. So I think having more people looking at this is absolutely a good idea right now. Gabby, I mentioned in the PR, but Radek and I were working on just specific, well, it doesn't have to be, but we were looking very narrowly at encode decode and allocating memory from ring buffer, a thread local ring buffer, rather than allocating from malloc to start out with, but using malloc as a fallback when the ring buffer, when you couldn't allocate from it, then you just fall back. I think if I remember right, we saw some advantage. Actually, it's been a while since I did this. The data is here, but it's very difficult to parse through it all. But I'll paste in case anyone cares enough to look at this. But the gist of it was that we saw an incredible amount of allocation. I mean, many gigabytes per second that was going through this thing. And I think that there's a huge amount of opportunity for us to do much better. That code never really made it into the code base. We worked on it for maybe a couple of weeks, and then we got into other things. But I think the idea behind it was actually really good. And it's something that I think if we could either resurrect.
What you're seeing in this table?
That's what I was going to tell you, is that it's been over a year since I worked on this. And as I look at it again right now, I'm like, holy smokes, I had a lot of data here. Oh boy. I used to understand what all of this meant at one point. If you look at, like, in the second tab, or even the third tab, that total fallback length, that was, I think, more or less the amount of data that was coming from malloc, and then that was like column H and then column D, the total alloc length. I think that was basically how much we were allocating from the ring buffer, if I remember right. aggregate across ring buffers.
Is this per second, per minute, per hour?
Let's see. That was probably the aggregate in total, if I remember right. But maybe it was actually, was it per second? I hope not. Well, in any event, it was. I'll have to go back and look at it again. Like I said, been a while since I've done this. But the gist of it overall, from what I recall when we were working on it, that we had a huge amount of memory allocations that were coming through for encode decode, and that we did see the behavior we wanted to see, where we were getting more allocated from the thread local ring buffer as we increased that buffer size. We could get to a point where we were doing like a lot of it from the ring buffer, and that then you avoid the lock contention overhead and avoid a lot of the problems that you have with TC-malloc when you have to fall back to allocating from the central space, which we did see happening.
Can you maybe just increase TC-malloc local buffer size? Because TC-malloc does maintain local buffer. If you just change the setting, maybe it's going to.
So we already do that to some extent, and that actually helps us pretty dramatically. I think what happened is that we see a lot of fragmentation with the thread local buffer because of the way that TC-malloc has to do it for many allocations across the entire process. Whereas for encode decode, we know we're guaranteed that these are short-lived. They only live as long as the current op. So when we do it in our own, we know that it's going to go away and that the ring is going to progress, fairly reasonably. We shouldn't have things sticking around, so that when you loop back at the beginning of the ring, as long as it's big enough, you're probably going to have free stuff or free space that you can work with, specifically for encode decode.
So why don't we just allocate space on the stack? It's the cheapest and easiest. And you always give it back, so there's no fragmentation whatsoever.
It's a good question. Maybe we do it that way. Maybe it's better. I don't remember. But, it's not.
I mean, there's a limit to the stack size. I don't know how much space we need for encode decode. I think stack size is limited to about 1 megabyte.
Yeah, I mean, it's arbitrary, right? It's whatever we're encoding, decoding.
So a single encode decode is probably a few kilobytes, no more than that. But if you do, and if you recycle the same buffer again and again, so you take local buffer on stack, and if you call it, then it should be fine.
Well, right now we walk through the entire structure of what we're encoding, decoding at once. We figure out all the different types of data that we're going to work on. Then we allocate one big allocation for it, and then we actually encode into it or decode into it, depending on. I guess if
stuff, we encode them one by one.
We work one by one, but we do one memory allocation up front because we've pre-walked the entire structure, figured out what the sizes are going to be, and then we actually we do one memory allocation. That was an optimization we made early on in BlueStore to avoid making lots and lots and lots of small memory allocations for every single structure.
But say we use like a constant 4K, 8K buffers and just pack everything inside it, then it's easy to recycle. And you don't need, so if it's going to be 7.5 kilobyte, we don't need to have the exact size. Just give it constant 8Ks and just keep allocating 1K, 8K on the. I mean, even the stack you could have enough space. And once, actually, sorry, take it back. The stuff that we encode decode, do we pass it as a buffer list? Because if so, it couldn't stay on the stack. It have to be long lived.
Yeah, that's probably true.
Okay, if that's the case, then you need a slab allocator or something like that.
Yeah.
And you don't need to allocate the exact size. It's okay to have, I don't know, power of 2 kind of buffers. So if you need 7K, give it 8K, but it's better than keep fragmenting the memory. Even 8K, you're going to give it back to you, and then you could reuse it.
So for append hole, we actually do that now. I made a PR that did that a little while back. Let me find it. Let's see. Refill append space. So this helped and appears to help in some cases. But the entire way that we do encode decode is kind of not ideal. Even just going through and doing that pre-computation of the entire memory usage is not cheap. Radek said that he's seen cases where that was ended up actually being slower than just doing the memory allocations up front. So, I think this whole area probably needs to be revisited.
For something like this, I would definitely use slab allocator or some kind of a body allocator. When you keep using power of 2, you use them and then you combine them afterwards when you free them.
Yep.
You don't need exact allocation size here. It's okay to have some space wasted. But like this, you don't keep fragmenting the memory. You don't need to work yourself out because you can just, the slab could be local to you. You could cache some stuff, some slabs. And whenever your cache is empty, you're not going to take 1 entry. You're going to take like, I don't know, 10 entries, whatever.
Yep, I agree with you, Gabby. I think that's probably superior to doing this scheme that we've got now. We'll just need to figure out how to change it. And it doesn't help that what we do in Blue Store with Denk, that's really the only place that we're using this new thing anyway. Where in most of the other parts of the code, like in the MDS, we're still using the traditional scheme where we basically just allocate as much space as we need for each individual piece of data, and we do it one by one by one.
I think that's going to lead to fragmentation. If you're going to keep asking for 7.5 kilobyte, then you're going to have a lot of empty holes inside, which over time the whole system is going to be fragmented and allocation is going to be slower and slower.
Yep. And even for like MDS journaling, we see both fragmentation, and we also see that the journaling process is very slow, spending so much time in memory allocation.
And we discussed in the past the possibility of doing, instead of encoding, decoding, doing binary storage. It is going to be cheaper.
Yes. I think there's a very good question of whether or not we should be encoding and decoding at all. I mean, it's like variant encoding theoretically isn't that expensive, and it does help if we have a ton of zeros all over the place, but maybe it's not worth it.
And that goes again to the first item. If the objects are not going to be dynamic but static with static tables, then this kind of object could be just give them the pointer and it's going to be binary stored. The reason you need encoding is because we have a B tree, so you have to walk the tree. Then we have a linked list, so you have to walk the list. And the memory is not continuous. If the memory is going to be continuous, then you could just dump it as is. So it's the whole thing is circling one after another. You need a way to build things, and maybe that requires even some limitation to the protocol. I know the protocol exists, so probably that's hard, but maybe there could be like a Gen 2 protocol that people committing to Gen 2 protocols, they're going to use predefined sizes. So if you're going to say your request going to look like this, everything going to. So when you use the Gen 2 protocols, we could just use structures, do one allocation, get the whole struct, and when we need to do serialization, we just take it as is, and there's no work that have to be done. And we could still do backward compatibility by, if you don't confirm to this new API, then we will still do the stuff. But hopefully everybody eventually would go and move to this fixed size thing. Like if you look at the mainframe protocol, the CKD, in theory, it could be any possibility. They have in the CKD, you could define a lot of possibility in how you're going to make the disk layout. In reality, what they do today is that they added few fixed size modes, and probably 90% of all I/O in mainframe is using like 2 or 3 fixed size modes. People still support all the crazy possibilities that you had before, but if people are writing new application for performance, they're going to use this thing. So maybe it's like a roadmap to the future.
I think version 2 is a good idea too, and currently we have all of these conditional situations for older versions of encoding, like in the MDS, and it's not as bad in like BlueStore since it's much newer, but there's all of these things to support stuff that was from 10 years ago, right? Like encoding that was different 10 years ago. We can, version 2, you could do away with all of that and just start over from scratch. It'd be probably better than trying to shoehorn in all of this old stuff.
And I mean, it's required that people would sit and look at the protocol and say, okay, in the past we gave a lot of flexibility, but what do people really use? Because if there's some option that people use once a day, and there's something people use all the time, then maybe you should eliminate that possibility in version 2.
Yeah. Wouldn't be bad to align it with Crimson, right?
Yes, I mean, it's independent of Crimson, but yeah.
You could align it at the same time, though.
Yes. So define a simpler protocol, and then all the requests and data structures should fit inside a constant size object. And the object could have some flexibility. So say, I don't know, attributes. I know it's an easy one for me. So at the moment, there is unlimited number of possible attributes. My understanding that in reality, we do like 4 or 5. So you could pre-allocate space for 8 attributes. And you say, you know what? I'm allowing just 8 attributes. If you need more than that, then you have to go and use the old API. And you could maybe even mix match. Maybe you could, every request you could say, I'm using, this request is using a new API, that request is using the old API. So everybody which could fit within 8 attributes, they would use the new API. People which need, I don't know, 27 attributes, they would use the old one. But then everybody will have 8 attributes, which is a bit waste of space because maybe people are going to use just 2, 4, whatever. So you need enough space, but usually, if you think about it, even given something which is going to fit 90% of the people, it's not going to be too much of a wasted space.
And really, is it more wasted space than we suffer right now from fragmentation?
It's not just fragmentation. Again, if you look at in B-tree, or I don't know, red-black tree that they have, every object got a lot of overhead because you got the right pointer, left pointer. All this, and everything's done with dynamic allocation. So that's another overhead because there's 8 bytes extra for every allocation. And I'm not even talking about, and then you pay fragmentation, you pay in memory memory layout, and then you pay that when you're doing dump or marshal, demarshal, you need to walk the whole thing. While if you'd keep everything as a vector, everything would be just sequential.
Yep, I agree with you,
Because
Gabby.
And I think that is what people are using on every high-performing systems. If you go back to early 90s, if you look at what Cisco is doing, if you look at the big database servers, this is what they do.
Yep.
If you have to deal with a lot of IOPS, then you need constant size. And I mean, if you look at the TCP protocol, all the structures, they are fixed. If you look in SCSI protocol, the structures are fixed. You could have some flexibility, but it's like 64 byte for the structure in FCP in the fiber channel. Maybe you don't need 64, maybe you could fit in 48, but 64 is enough. But you cannot have more than 64. You're not going to have 47 bytes. So everything is just recycled again and again. So you never have to do any dynamic allocation. They keep a pool of, I don't know, 4K object of 64, and they keep recycle.
Yep. Yep. I think that's what we need to move to. Even in Crimson, we're not going to see the benefit of everything else unless we do this.
I think so. I think memory access is a big killer if every object need to be working from different locations. Especially if the memory is fragmented and say you allocate a linked list with 8 objects. But because the memory is so fragmented, the first one is going to come from that page, the second from that page, and you keep bringing cache line. Every time you access one, you walk the list, you have to walk a lot of memory pages, which is going to pollute your cache and so on. Get everything into one page, one continuous buffer, continuous memory range.
So do you think you're going to try to take a stab at it, Gabby?
Actually, that'd be interesting. Yeah, I would be interested in doing this kind of project. I know it's a refactor, meaning it's not going to add new functionality, but I think that had the potential of serious performance increase. And we could start one by one. You don't have to do the whole system at once. You could start with one object type and then measure what kind of impact it does, and then fall through. It could be start easy. And once you do it for one object, you realize how you do it, and then you could start doing this one object after another. But it's not going to be done as nicely and generic as this thing from IBM. The IBM thing was you don't understand the system. They don't claim to understand. So they just make something. So in our object, they would use these things, and they will call malloc again and again and again for the same object, and they're going to get a lot of recycling. But if you understand the system, you would get one object at once.
Yeah, that was kind of the same way with the thing that Radek and I were working on. Well, we're not going to change the entire code base. We're just going to try to make the behind the scenes, make it a little better because we have some knowledge that, at least for encode decode, we know it's going to go away soon, as opposed to other things that may or may not go away soon. So maybe with that knowledge, we can make it a little better.
And if you find like what object are your worst hitters, then you deal with them. And there's still going to be a lot of small things which, I don't know, management and telemetry, like all this stuff that doesn't happen so often. Okay, so it's going to stay and going to use dynamic allocation. But your big object, they're going to be pre-allocated and used from a single pool. So even if memory is going to be fragmented, your main data object are not going to be affected because they have all the memory pre-allocated. And then another thing that you do, which is again, it's one of the principles of system design. When the system is coming to a place that you are reaching your service level, you start to trash. So usually you build a system in a way that you say, I can service, I don't know, 1,000 requests in parallel while giving you some predictable response time. I don't want to go to like a spike of 5,000 because it's going to cause the performance to be very slow. So once you reach 1000, you're going to start rejecting things or just queue them, but don't process them because it's going to impact your performance. So just keep like a minimal request, but don't start processing them. So that also means that you know how much space, how much memory you need, because you're going to set your own limit. You say, I don't know, 1000 parallel IOPS are going to happen. 4K, I don't know, you set the numbers. Anything above that, you just queue them and you don't allocate resources aside from the request itself, which is a relatively small thing.
It's nice too, because if we do this right, it means that all of this memory auto-tuning stuff that I've written becomes obsolete, and I want it to go away, right? It's trying to dynamically account for changes that are happening to keep us below a certain memory limit. But if we just are smart about the allocations up front, then we don't need to do any of that. We just have our pool memory that is static anyway.
I mean, that's like the base design principle. Actually, since the early 80s, people have been using this kind of principle.
Yep.
You know how your system behave, and then like in the old Unix, you would have your limits. And when you change the limit, it's just going to assign how many objects you could process at once. If you're going to limit that, you cannot have more than that many processes happens. And everything is pre-allocated and everything is working. If you need more than that, then you need to change the settings.
Yep. All right, I think we've beaten this one to death. Almost all our time.
Yeah, I would be interested anyway in diving into this and actually starting slow by making a single change. Then, if it seems to be useful, and add more things.
Encode decode is definitely a high impact area. There are others too, but that's one of the ones where we have two ways of doing it, the old way and the new way, and both are kind of bad in different ways. So that'd be, somewhere to start to see what are we encoding, what are we decoding, what of those things can we start changing, maybe. See what which objects are the most common, right? And then you could look at the structure of those objects and try to figure out, can we write these out differently and have them behave differently?
And that's bringing back to something I mentioned a long time ago, that we need to have stat counters about object. How are we using them? Like if you could have that many, I don't know, what's the max object size? How many fields you can have in, how many subfields you can have, and then put them in buckets, 10%, 20%, like 90%, and so on.
Yeah.
Then you could design your system to match your customers.
I get the feeling that a number of these lists or even unordered maps that we have the ability to have an arbitrary number of entries, but we only use maybe one or two of them typically. I might be wrong, but that's the feeling I get from having looked at this in the past. We'll see. All right, well, we're almost done here. I'll just add the two discussion topics here. I'm doing a Q3 update for Crimson, just trying to get more data for that. I'll talk about it later on, but right now, just trying to collect it. There are a bunch of PRs that just went in for CBT that add some support for Crimson and other things that I had kicking around that I needed to get in. So maybe some CBT improvements coming. And that was all I really had. So in the last 8 minutes here, anything else that we want to talk about before we wrap this meeting up? I don't hear anything. So, what do you think, Gabby? Are we done on that other topic, or is there anything else that you want to?
No.
Oh,
I'm good.
all right, cool. I very much think you should. You should dig into this. I think it will be important for us. Um, if you do, let me know. I'd be interested in seeing what you find.
So maybe we take it offline and try to do this later.
Yeah. Do you think we would start out with like stat counters just to start getting a better idea of what we have?
So that could be one option. Another option would be just to guesstimate how much you need from something and then see if there's some object which are well understood that you don't even need to analyze. I don't know, like if there's some object that you could say that's the number and I don't need more than that. And then stat counters, of course, are always good.
You've looked at the Blue Store data structures more than I have. Do you remember, as you looked through them, what the bigger dynamic uh, elements there were in blobs and shared blobs and these things? I remember there's a fair amount, but it's been a little while since I looked at them.
Let me look. There's actually quite a lot of data structures.
Yeah.
Because you have, yeah, actually,
Adam, you feel free to jump in too. I know you've looked at this far more than I have lately.
I did, and I guess Igor did. So it's so much that I don't want even to start 5 minutes.
Yeah, well, actually, blobs and shared blobs are pretty good candidates for being the most numbers entries. So just simple estimation. You have a single node with multiple blobs, and well, depending on your spatial fragmentation, you might have plenty of them per single node. So it likes order of magnitude higher than amount of blobs is like order of magnitude higher than number of nodes usually. And in fact, we have some means to count, well, at least shared blobs and nodes and things like that in RocksDB. And also we also have performance counters showing nodes and something else, some additional parameters in the memory, which are in the cache. So you can learn the ratio between a node and other entries.
We don't care about like. Sorry, Gabby, what was that?
no, I was asking Igor if you think the extent map could be made instead of a map just to be an array.
Yes. So, well, actually, you might take a look at my PR, which is pending, where I tried to optimize this memory footprint for many of data structures. Unfortunately, it's hard to get rid of dynamic allocations as we do not limit number of entries in our data structures, and this might impact existing users, and this reduces the functionality, the flexibility, and things like that. So at this point, I could maybe think about two different implementations of the Blue Store, or maybe something like fast bool store, which has got limited functionality at cost of high performance. But I'm not sure it makes sense to refactor the existing bool store. It would impact existing users most probably.
Yes, we based a lot of our algorithms on entries being dynamically added, and we then split them dynamically, and changing that will really impact not even data structures, also even some decision process like when to recompress compressed chunks. That also will be affected if you change data structures. So basically, I do agree with the idea that we could reduce the dynamicity in BlueStore objects, but I'm a bit scared with the scale of this entertainment.
Yeah.
What about starting easy with just a request buffer? Every time there's a new IO coming to the system, there's a request buffer. Could we just create a pool of requests? Because that's the entry point. The requests be of different sizes, or are they more or less of a constant size? Or maybe
They are any size. There's very soft limit on the size of request that comes
so the
to
request
object store.
includes the data. Do we send the
By
data
request, I mean an entire transaction from OSD to object store.
No, I'm talking about request from RBD client to the OSD. Is the request including unsolicited data, or the request is coming and eventually when the OSD have time, he asks for the data?
I don't understand the question, sorry.
When an RBD client send a write request to the OSD, does it send a request and then the OSD said, okay, now give me the data? Or can he send the request with the data?
It's a single shot operation. So it issues the write and it's processed by the no preliminary request if it's possible to perform writing.
So the data is piggyback to the request.
Yes.
Maybe we want to change that.
But you will get duplicate latency this scenario.
That will cause some latency, but not too much, because the latency that we incur is already milliseconds. So
okay, and okay, so well, it would be just a duplicate round trip from client to the primary OSD, but what are you going to get from this?
To allow the OSD to control the flow and to control the amount of requests happening in the system and the amount of data per request. Also, so the data for the request, how do we allocate the buffer for the request data? What happens if you send a request of 8 megabyte? Do you send the data or do you wait?
You mean client?
Yes, if the client does a write of 8 megabyte, does he send the data or does it have to wait for the OSD to tell it, give me that amount of data?
Well, definitely doesn't wait until additional confirmation from the OSD, but it it could postpone sending additional data. So instead of sending like 8 megabyte, it might send less in less portions. But it actually depends on the client. Some different client might behave differently.
If we don't have the space or the already filled the number of IOs we can handle or the amount of space that we can handle for ingest, do we just reject it? I think that's what I remember it happening. Like if we don't have the amount of buffer available.
Honestly, I've never seen any issues with data rejection or either behavior like that, but maybe it's
Our buffers are pretty big, I think.
And are those buffers being dynamically allocated? Or are we recycling some slab allocator buffers?
most probably they are dynamically allocated.
Yeah.
I'm not sure about the details, but to be honest, the current bottleneck is not in the allocation itself. It's rather some interlocking between different tasks or things like that. So these dynamic allocations bring some additional overhead, but it's not the primary one. It's my feeling and my experience that what I've observed before. So
Igor and Wildcloud profiles, I've definitely. Oh, go ahead. Sorry.
So you can try to improve these things, but most probably they wouldn't bring much benefit at this stage.
That's a bit weird because all data servers, typically data servers don't allow unsolicited data because they don't want, because they are the one controlling the system, not the client controlling them. Because client could overwhelm a server by just sending huge amount of data.
I agree, but I think the difference between Ceph and these other devices is that we've got pretty powerful CPU here, and we are not getting that many IOPS at the moment due to different reasons. And that's why we are not affected that much by these inefficient allocations and things like that. So, Mark, please correct me if I'm wrong, but I think we can hardly reach more than 100,000 writes per OSD per second.
Yeah, but if the write is going to send 1 gigabyte of data, that's going to be pretty sad for us.
That's a question. Such writes are considered as bad behaving clients, and we fix that at the client side rather than. So we are not dealing with arbitrary client. We will have our own implementation for RBD at client side.
But the SCSI
SCSI has to deal with custom user, but we at Ceph backend we are dealing with our own clients, and they are behaving more or less gracefully.
So that number, the 100,000 writes per second, you're right, Igor. And now, especially with Gabby's work on the allocation improvements, we've gotten to the point where the TP-OSD-TP threads are actually very busy when we do that. The KV-sync thread is still kind of a bottleneck, but those our worker threads are actually very busy. What they're busy doing, there's lock contention involved, there's memory allocation, there's object creation and destruction. It's spread over lots of stuff. We got other things. CRC is another thing that shows up. We've got various random things, but we are very busy. CPU is probably near the bottleneck with 16 threads. With 100,000 array apps, we'll use almost all of it.
Mm-hmm. Mm-hmm.
We cannot just redesign the whole system. So let's try to find maybe something in BlueStore that we could mess with, or some other data structures in the common path. Maybe the read request. Okay, so write they send data, but read they just send a request, so there is no data. Can we recycle them? Like if the RBD client sends read request, I assume we could use a predefined request buffer and then recycle them. How about that for a start?
Yeah, I mean, it's worth trying. The easier it is to experiment with, the better, right? If we can try things that we can then see if our assumptions are right or wrong, that'd be very good.
At this point, I would bring a bit different idea. A while ago, I was doing some experiments with Messenger, and it looks like we have pretty significant overhead in Messenger itself. So maybe instead of trying to fix everything, start with just one component like Messenger.
I think you're absolutely correct. We should find one component which is easy to change, and then see how.
Yeah. And I believe I could see pretty inefficient operations at Messenger level, and just a simple round trip to OSD and back could take pretty significant amount of time if multiple of them are going. So I would suggest starting optimization in areas like that rather than trying to do some tricks with allocations with some non-mainstream exchange and things like that. So most probably you wouldn't get anything from that experiment. Again, my feeling that Messenger might be one bottleneck. This PG logic and the interlocking there, it's another bottleneck. RocksDB, the third one. But and they probably hide all this inefficiency in allocations and like that. Just my thoughts. I'm definitely not. I'm not absolutely sure about that, but seems to me something like
that. Side note, I pasted in the chat the OSD client message size cap and OSD client message cap. I think those are governing when we reject pulling new data off the network.
Mark, I have to leave.
Okay, we're past time anyway, so
yeah,
we should move forward on this though, one way or another. Even just trying to make small progress, I think it's a worthwhile pursuit.
Yeah, so I think at first we need to find the best candidate. Maybe that's the messenger that Igor was pointing, maybe something else. So we should try to look for a good candidate which is simple to define fixed size object and then set the number of them and then start using them and see what kind of impact, if any.
Sure. I'll try to get some more wall clock profiles available for folks too, and then maybe that will help us determine areas that might be worth looking at in more detail.
Yep.
All right. Well, have a great week, everyone. Thank you for coming. It was a really good talk.
Thanks.
Bye.
Bye.